Hello and welcome back. We are in a new section. This section is all about file input and output, writing and reading from files. We are going to concentrate on text files, but we talk about binary files a bit as well. In this lecture, I just want to provide an overview, tell you that a file is and tell you how it's good use for storing persistent data. So up until this point, all the data that our program access is via memory. We are familiar with this concept of variables, structures, whatever it is, arrays, all the data that your program uses is in memory. And the reason that it's stored in memory is because memory is really fast and you can access it quickly to perform calculation. You are doing the fetch, execute cycle, all that stuff. But it also is limited because the scope and variety of our application, if it only use memory, it's going to be somewhat limited. We know that memory goes away when the program goes away, and so that can be very limiting. All serious business applications require more data than would fit into main memory. Main memory is also very small. Nowadays you can get a lot of memory, 16, 32 gigabytes, but in the past and especially on embedded devices, you don't have as much RAM. And as a result, your applications are very limited because of space and size. You really only want to store variables and things like that in main memory. It also, because main memory goes away when the program goes away, you can't have any data that is stored persistent across reboots. So it all depends on the ability to process data that is persistent and stored on an external device such as hard disk drive, these big programs. So you want to have this ability to store on the hard drive. It's a little bit slower, but you can store a lot of data on there, and big programs that need to store a lot of data. C provides many functions in the header file. Standard IO.h for writing to and reading from external devices. You don't have to write your own code to read and write the files, but you can see the advantage that applications offer that have the ability to store data for a longer amount of time. A lot of advantages. The external device you would use for storing and retrieving data is typically the hard drive, the disk drive. However, the header file functions that we are going to talk about, you can use on any external storage devices. You can, so you could use it on a USB drive. You could use it on any external device that stores data and STD, SSD drive, anything with all the examples up until now, any data that the user enters is lost once the program ends. This is referred to as volatile memory. Whenever you heard that term, volatile memory, it means that memory is not persistent or the data is not persistent. It goes away when the program ends or if the machine reboots. So if the user wants to run the program with the same data, he has to enter it again each time so that it gets stored, restored. It's very convenient. It's limits programming. And again, this is volatile memory. When you store stuff in files and you store it on the hard drive, this is permanent storage. It's still there even when you reboot the machine or when your program is not running. This referred to as non-volatile memory because it stays around. A file can store non-volatile data and is usually stored on the disk or nowadays a solid state drive and SSD. It's a named section of storage, and the standard IO device is a file containing the use of information in order to be able to read and write to those files. But we are going to use this concept of writing and reading data from a file for permanent storage. And you are going to notice how your applications become much more useful, much more robust, much more scalable, because now we have the ability to store large amounts of data, and we also do not have to worry about the data going away whenever the program ends or the computer reboots. So it's going to be very, very advantageous to use files. A file on the Linux operating system or Windows operating system is stored a certain way. But as far as C goes to programming language, it's just a sequence of bytes, and each byte can be read individually. This corresponds to the file structure in Unix, but it only makes a difference when you are reading text files and Windows, because you may have extra characters that you have to worry about concerning size, but it's just a sequence of bytes. So if you have a text file and it has more bytes, you can still read those bytes. You just have to understand what those bytes are representing. So here's what a file looks like, how we are going to read it and write to it using the C programming language. It's just a series of bytes with different offsets. The beginning of the file would be by 0, and then you can always find different positions in the file. Could be 4 bytes into, could be 100 bytes into it, and then you have the end of file, and the end of file is usually marked with a special marker called end UF or end of file. So file has a beginning and end, and the current position. The current position is defined so many bytes from the beginning. The current position is where any file action will take place. You are going to write or you are going to read a function where you are. And we are going to also talk about some function where you can move around to move the current position anywhere you want in a file, even at the end. If you want to read at the end or write to the end, there are two types of files. There are text files and binary files. A text file is data written as a sequence of characters organized as lines. Each line ends with a new line, and the text data can get vary from system to system depending on how characters are interpreted. So for example, on Windows and every line has a carriage return and a line feed, so a backslash r and a backslash n. And so when you read the data or write the data, you have to understand this because the formats is a little different. But on Linux, you don't have a backslash r, so you have to understand how the text data is written. Even though it's organized by lines and it's series of bytes, binary data is written as a series of bytes exactly as they appear in memory. So examples of files that have binary data are files like image data or music encoding. Binary files are not readable if you were to try to bring them up in a text editor because they are just bytes. We are going to concentrate on text files in this section. But you can write any data you like to a file. You can write it as a series of bytes and how they appear in memory, or you can run it as a text. But once the file has actually been written, it's just going to consist of a series of bytes, even if it's represented as type text. You can view text files in an editor, which makes it more readable. You have to understand that the format of the file in order to read it. And this is what I mentioned with if you are running on Windows or Linux, where Windows may have extra character when it writes data. So a sequence of 12 bytes in a binary file could be 12 characters. It could be 12 bytes and signed integers, or 12-bit unsigned integers. Binary files are especially tricky because they just store as they appear in memory. They were. So in binary mode, each and every byte of the file is accessible, but in order to read something from the file, you have to understand what's in there as far as data and how it's stored. And it may depend on what system you are running on. And it's going to also depend whether it is text or binary. Stream C program are automatically open on three files on your behalf. A stream can represent a file, but a stream is more generic term that can represent any kind of input. So it could represent the keyboard, it could represent the console, it could represent a file, it could represent a socket. If you are used to networking, streams are a more generic term, and they are three streams that are opened up automatically for you in the C programming language. One is the standard input, and this is the normal input device of your system. Usually by default, it's the keyboard. We have been using the standard input, then we can use scanf. But you could actually use scanf to read from files if you change the input stream. Maybe you change the input stream to a file, a standard output. This usually displays on the screen, usually via the console. A standard error is also on the screen, but you usually have to redirect it in order to see it using like the ampersand 3 or something like that. But these are the three outputs. I mentioned standard input is the file that is read by get, char, and scanf. Standard output is used by put, char, put as, and printf. We have mainly been using printf. You can also redirect files on the system to be recognized as a standard input output. This is redirection. This is an operating system concept where you can redirect data, send the output to a file. For example, you get input from a file as opposed to standard archive. This is where you can use the lesser than or greater than symbols. The purpose of the standard error output is to provide a logically distinct place to send error message. So it's kind of separate, even though it's displayed to the screen. To access it to you have to special command. A stream is abstract representation of any external source or destination for data. This is why it's more generic, they say a file. The keyboard, the command line on your display files on a disk, those are all examples of how you work with the streams. Streams are going to be much more important when you start studying C++. The C library provides functions for reading and writing or to or from data streams. So you can use the same input output functions for reading and writing any external device that is mapped to a stream. That's why I mentioned you can use scanf to read from the keyboard. You could also use scanf to read from files. It all depends on what the input or where the stream is pointing to. And so the functions are very, very useful and very, very flexible to do this. And so this is just a high level overview of what a file is and why would use it, how it is persistent data, it's non-volatile memory, it stays around. We are going to use it, and we are going to use the standard input output header file to read and write to it when we need to store data for our program. And our program end up being a lot more robust, a lot more usable, a lot more flexible. So in our next lecture, hello and welcome. In this lecture, I want to talk about accessing files. So files on disk have a name, and the rules for naming the files are determined by your operating system. You may have to adjust the names depending on operating system your program is running. If your program is running on Windows versus Linux, the actual directory structure is different as well. So if you use forward slashers or backward slashers, you have to adjust this in your program. But for the most part, the names are relatively have the same naming rules and so forth. But there is the chance that you have to adjust it. A program references a file through a file pointer or a stream pointer. Since it works on more than just a file, you can actually, we mentioned this earlier, but the standard IO function work on any device. So it's called a file pointer, but it's really should be referred to as a stream pointer. You associate a file pointer with a file programmatically. When your program is run, So what you end up doing is you will create a pointer inside your program. It will be of type file, and that's going to represent the file. When you read and write to it, we use these file pointers as a more effective way to actually point to the files as opposed to the name, because the name can be a little bit different. The pointer will represent what it's actually different files on different occasions, which again was represented by the file name. A file pointer points to a structure type file that represents a stream. You can actually go and look at the file extract to see everything that's inside of it. But it contains information such as whether you want to read or write or update the file. The address of the buffer in memory where you are storing data, a pointer to the current position in the file for the next operation. We mentioned the position is important because that's where you are doing your writes and reads, and you can set all this information inside the structure by using input and output file operation. The input output file operations, when you open a file, it's going to actually specify whether you want to read or write, and then uh, also you can change the current position by using other methods like seek and so forth that we are going to talk about. If you want to use several files simultaneously in a program, you have to create a separate file pointer for each file. You can only reuse the file pointer if you are reading and writing at different times. There is a limit to the number of open files you can have at one open time. You can look at the limit in the standard input output. There's a constant defined f open max. It all depends on again what operating system you are running on, but you usually do not want to create and open a ton of files at once. Writing and reading these files is an expensive operation because you are writing on the hard drive. It's not as fast as writing the memory, so it takes time and it can cause your program to be less responsive. So you don't want to have 10 files open and writing at 10 files at the same time. To open up a file, this would be the first step that you do before you read and write. So you want to associate a specific external file name with an entire final pointer through a process referred to as opening the file. The way that you open a file and see is you call fopen function. This will return the file pointer which you can then use for reading and writing. And again, the file pointer is going to point to a specific external file that's on the disk. Fopen is going to take the name of the file. That fopen is what you have to do before you do any reading, writing. It's usually your first operation. And as with most of these functions, they are all defined in standard io.h. Here is the definition of the fopen call. You will see that the return value is a file pointer. It's all caps, the file structure. So L all caps file. You will then notice that it takes a couple parameter. It takes a name and a mode. And don't worry about this restricted. That's just more C11 step. It's really just takes the character pointer to a name and a mode. The first argument of the function is a pointer to a string that is the name of the file. So that will be inside double quotes. You can specify the name explicitly or use a character pointer that contains the address of the character string. So all this is saying is you could create a character string and assign it to literal text and then pass in the string to the function. Or you can put in inside the double quotes right inside the function call. You can obtain the file name throw the command line as input from the user as well, or define it as a constant your program. If it's always the same file you are reading, writing to, and the name does not matter, you can just refer to as a constant. If your program is more flexible, it can get input from the user to say what you want to read or write to the second argument to the fopen functions is a character string that represent the file mode. This specifies what you want to do with the file, whether you want to read it, whether you want to write to it, whether you want to append to it. A file mode specification is a character string between double quotes, and I will show you some of the ones that we are going to end up using a lot of. Assuming the call to fopen is successful, it will return that file pointer, all caps, and then you can use the file pointer to call other input output functions in a standard IO header, and we are going to go through those when we go through reading and writing. You can also get the position using that pointer to change the position of where you are in the file. If the file cannot be opened for some reason, fopen is going to return null. So what this means is, before you start doing any reading or writing, make sure that the pointer is not equal to null. Another if check here are the file modes that I mentioned. The file modes, remember, are the second parameter to the fopen call. This is what specifies what you want to do with the file, and it's all inside double quotes. So if you do a write W, that means you want to open the text file for writing. If you want do an A, that means you want to open the text file for appending. All writes R to the end of the file. If you do a R, it opens up the text file for reading. If you add a plus to A plus to any of these, it will basically create the file if it does not exist. If you open up a W plus file, it will open it up for update, and it will truncate the file to 0 if it exists, or it could create a new file if it does not exist. With the other ones, it's going to write or read, and the file has to exist. Same with the plus, it's going to open it up for appending for an update to the end of the existing file, or create the file if it does not exist. And the R plus will open up the text file for update. It's not going to create the file there because it will be empty. So the reading is just for both reading and writing, where when you see the R plus, a little different than the other places where they are actually creating the file. It does not exist write mode. If you want to write to an existing text file with the name myfile.txt, you could create your file pointer, all caps, set it to null, initialize it the null, and then you could maybe create your file as another character pointer myfile.txt, or you could pass that in as the first parameter, and then you just say fopen. Fopen file name, and then W inside double quotes that opens the file for writing, and it returns a file pointer. That's why you have P file on the left of the assignment. You then want to check to make sure P files not equal to null, because if it is null, if it failed to open for any reason, maybe the file name was wrong or it did not exist, then you would not be able to write to it. So you always want to do the S check and print out some information if it does not open. This code will open up the file, and it will associate the file with the name myfile.txt with your file pointers fp file. The mode W means we can only write to the file, you cannot read from it. If a file with the name myfile, that text does not exist, the call to fopen will create a new file with this name, and that's for fopen with the W option. And so when we saw in the previous modes, W plus will create the file if does not exist, but it also truncates the file to 0. That's the different with the W. The W will create if it does not exist, but it's not going to truncate it to 0. So this is the standard way for opening up files using that W inside the double quotes. If you only provide the file name without any path specification, so that's what we did in this example. A path, remember, is the name of the directory. If you don't provide the name of the directory, it's going to assume that the file is in the current directory wherever the program is executing. If you want to actually open up a file somewhere else where it is not actually located in the program's directory, then you have to specify the entire path. That's called the absolute path. When you provide no path, it usually the relative path. It's relative to where the program is running. So you can specify either one, the absolute or the relative path. Just make sure you know where it is located and you are doing the right one. Relative paths are usually better because then it's not independent. If somebody would have moved that file, it's not dependent on where it was moved, and you can actually do a relative path and you can go back directories. So you can do a dot slash and that's relative to where the program is running. You are just going back a couple directories when you use an absolute path. It would actually be something like C colon program files if you are on Windows. And if that file ever moved, the program would not be able to open it. So on opening a file, for writing the file, link is truncated to 0 and the position will be at the beginning of any existing data for the first operation. Any data that was previously written to the file will be lost and overwritten by any write operation. So again, without providing the plus on it, it just means you can't read and write. This is write only. W is write only. W plus means you can read and write. Append mode. If you want to add to an existing text file rather than overwrite it, you can specify the A mode. This is depending, this positions the file at the end of any previously written data. If the file does not exist, it creates a new one. The example here is you just change the second parameter to be an inside double quotes. It will add to the end of myfile.txt. And do not forget that you should always test the return value for null each time. You always want to do the if p file is not equal to null. When you open a file in append mode, all the write operations will be at the end of the data in the file. In each write operation, all write operations append data to the file, and you cannot update the existing contents in this mode. It's all at the end. In read mode, we can open up the file to read a file. We just use the R inside double quotes. This is read only. You cannot write to the file. If you do R plus, you would be able to read and write. So it looks like the other calls. You just do an F open pass in the name of the file. And if you do R plus, you would be able to read and write. So it looks like the other calls. You just do an F open pass in the name of the file and then R in double quotes that returns a file pointer. We will also position the file to the beginning of the data. If you are going to just read the file, it must already exist. So you are not going to read an empty file. So there is no option of creating the file. It does not exist. It will just be empty, or you would get back the file opponent would be null. If you try to open a file for reading, it does not exist. It will return the null pointer. If it does exist and it's empty, you just will return no data. You always want to check the value written from F open again. Reading that for the second time, it's important because if it's a null pointer, your program is going to crash. It's going to do something bad. Renaming a file, we know now how to open a file. Opening a file is the first operation. You specify the mode and the name of the file that gives you back the file pointer, which you can now use to do other things with renaming a file. Is sometimes important. It's very easy You just use the rename function. It takes an old name and a new name as constant character pointers, and it returns an integer that returned with a will be 0 if the name changes was successful and non-zero otherwise. The file must not be open when you call rename, otherwise it's going to fail because it is in use. You can't rename a file when it is in use. What you can do here is you can just say rename, pass in the old file name and new file name. In this example, we are using a path to a file in Windows, and that it's Windows because I see colon. You also notice that the backslash is there twice. The reason for that is because the backslash is a special character in C. Backslash n is a line feedback. Backslash r is a carrier return. So the backslash has a special meaning in the program. So if you want to actually use the backslash for a path in a directory, which is what Windows does, you have to provide two of them. And so here we are renaming our myfile.txt, locating the temp directory. We rename it to myfile underscore copy.txt in attempt directory. And if that is not equal to 1, it will fail. We just print out an output that says it failed. Otherwise, you print out successful. This is going to change the name of myfile.txt in the temp directory to myfile copy. If the file path is incorrect or the file does not exist, it is not going to be able to rename. You can also close a file, and you want to do this whenever you open a file. So when you are done with the file itself, you want to tell the operating system to free up that file. Remember, there is a limit to how many files you can have open at any given time. You can do this by calling the fclose function. Fclose accepts a file pointer as an argument. Remember, the file pointer represents the file. It's written an EOF, end of file, is an int. Returns EOF if an error occurs. EOF is a special character called the end of the character. It's defined in standard io.h as a negative integer. It's usually equivalent to -1. If fclose was successful, it will return 0. So you can check for EOF for unsuccessful. You just say fclose pass in the pointer. You can then set the pointer to null, and the result of calling fclose is that the connection between the pointer, the p file, and the physical file is broken. P file can no longer be used to access the file for reading, writing, or appending or renaming. If the file is being written to the current contents of the output buffer are written to the file to ensure that the data is not lost. So you don't have any problem with data integrity. You are not going to actually close the file if it was being written to in another thread. So it's thread safe. We have not talked about threads. That's more advanced concept, but it's where you can have multiple execution points in your program. It's good programming practice to close a file as soon as you have finished with it, just like it's good same for closing files. It protects against output data loss. You must also close a file before attempting to rename it or remove it. It has to be closed. It cannot be opened. How about deleting a file? You can delete a file by invoking the remove function. This is also declared in standard io.h. All the file operations are declared in standard io.h. You can always go look at this header file if you want, wherever the C header files are installed. So you just say remove name of the file. Here you don't have to use the file pointer. So you can just say, because the file does not have to actually be open to remove it. The same with the rename, because you don't actually want the files to be open, because the rename or the remove will fail. It's going to delete the file that has the name myfile.txt from the current directory. This is providing a relative path. It's going to look for that file wherever the program is executing. Otherwise, you need to provide an absolute path. The file cannot be open when you try to delete it, just like rename. You should always double check with the operations that deletes file. You could check your system if you do not. Delete is a very expensive, very hazardous operation. Deleting files can cause problems, so be careful. All the information in this lecture had to be do with accessing files, how you can open up files, which is what you need to do before you read and write, and also how you can delete and rename files, and then closing when you are done using them. Everything is based off that file pointer. So understand that file pointer and the structure it contains pretty useful stuff. The standard IO header contains all the great information. Next couple lecture, we are going to talk about reading and writing to text file. Hello and welcome back. In this lecture, I would like to talk about how we can read text from a file. For now, we are going to concentrate on reading text files. So if we want to read characters from a text file, we are going to use a couple function. First one is going to be fget. See, this will read a character from a text file that has been opened for reading. Remember, we always have to open up the file before we can perform any file operation on it, unless it's rename or delete, and then the file cannot be opened. But if you want to do reading and writing or appending, we have to open that file. We know that we can open up files with different modes. In this case, for reading, we have to open up with an R or an R plus, and then we can start calling fgetc. Fgetc function takes the file pointer as its only argument, and it will return the character read as type int. So here an example, we create an mchar type int and we say fgetc file. It's going to read a character into the mchar variable with the p file as a file pointer. Think of p file already been opened, return it to file pointer. The mchar is of type because EOF, which is our special character, our end of file, that's returned if the end of the file has been used. So we can always check that integer to see if it's EOF. And if it is, we don't want to read anymore. We don't want to call fgetc anymore. The function fgetc, which is equivalent to fgetc, is also available. So getc is almost the same as fgetc. You just want to use fgetc. I think it has some more protection in it with getc. It requires an argument of type file star and returns the character read as type int. It's virtually identical to fgetc. The only difference between them is that getc may be implemented as a macro, and we don't even know what a macro is now. So we are going to stick with using fgetc as our function to reading characters. You can read the contents of a file. Again, when necessary, you can use this rewind function, which positions the file that is specified by the file pointer to the beginning of the file. So you can use rewind if you want to read again. Just say rewind and then the file pointer, pretty basic. So here's an example. You have to include the standard IO header whenever we do any file operation. In our main function, we are going to create our file pointer. If I want to initialize this to null and we are going to create an integer, first thing we are going to do is we are going to open up the file using the f open call, and we are going to specify the name of the file, and we are going to specify that it's for reading. That will return our file pointer. So now our fp pointer is pointing to a valid file. If it was unable to open file.txt, that's not in the right path, or whatever, it's going to return null. So you want to check for null, make sure fp is not null. If it is null, exit the program. Otherwise, when you usually read characters, you are going to have them inside of a loop. So here we are saying while c equals fgetc fp, this is reading a character from our file, passing in the file pointer to fgetc, which returns an integer. Remember, we can jump out of the loop if that integer returned is the end of the file, because we don't want to read past the end of the file. Otherwise, we can just print out our character using %c. And last thing we want to do is we want to close the file. We then want to set our file pointer to null, and we can return. Let's try utilizing this, creating this inside of code blocks. Here is our program inside code blocks. It says the program not going to work unless we have a file on disk wherever the program is running. So first, if we build this, it should build okay. It should create an executable somewhere on your hard drive. I have been putting all of my projects inside my .launch directory. So if I go to my downloads directory and I go to the project name, this is just a test project. So wherever you are storing your projects, mine's in test. If I go to test, you will see that inside the bin directory, inside debug is your executable. Here's where you create your file if you had a relative path. So here I could just create a new file and we can have it as text. So file. So I can just create it as text document and it has to be named file. And then I am going to put some information in it. I'm just going to put in some data such as, hi, this is JSON file feed. Okay, no. So fourth, I am going to save it. This file has to exist in order for this program to work. So I created the file. Now, when I run it, hopefully it will read and what I just added to it and it out, it says error and file opening file, no such file directory. And that's probably because I have it in the debug folder and this is not running in debug. So let's try running it in debug, and I think it would probably work now. We can say debug start. This will look for the executable in the debug directory, hopefully. Sorry. We want to make sure it's run. It's still not there, so you have to make sure you know where the executable is. Let's try somewhere else, or better yet, I could just run the executable inside the debug directory and should find it there. So if I double click here, it actually does not pause, it jumps out. So what you can do for that is, instead of returning, you can say system pause and it would not exit the program until you have run it. So let's now try it. So now paused did not execute the program. And what you saw was, hi, this is JSON. It was able to find the file, printed out. Okay. Printed out, nope, and then it paused. Otherwise, when you execute the program, it prints the data. It prints the data that you want to print on the output screen. So fast and exit the program that you are done. So that's how you can test it. It must be stored where the executable is stored, where it's running from. It must be running from somewhere else in your project directory. I'm not sure where it's running from. We could try moving the file to where the source code is. It might be running it from here. So here we will put it in here, and now we'll try running it from the ID and maybe it will work. We don't build, we run it and it was able to find it. So it looks like we have to put the file inside of where the source code is. So as long as we put that file.txt inside the project file, you will be able to see it. So quick example of how you can open up a file and read single characters, not the most efficient way to read from a file, because usually you want to read strings, but this will open it up. You see the f open call and you notice the while loop. That's important. Let's go back and talk about how we can read strings from a file, which is much more efficient. So that's reading a single character. How about reading a string? You can use the fgets function to read from any file or string. This will read a string. It takes a character. String has the first parameter, the number of string characters you want to read, and then the actual file pointer. So this function is going to read a string in the memory area pointed by the str. So you have to actually pass in the buffer where the data is going to be stored, and that's pointer you had have to allocate memory for it, and then it's going to read from the file specified as a third parameter, which is the file pointer. And then nchar is going to say how much data to read. So if you put mchars as like 10, it's going to read in 10 characters unless it hits a line feed first. So it's going to either read an entire line, or it's going to read the number of characters that you specify in the second parameter. The end of line is specified by the backslash n, whichever occurs first. If a new line character is read, it retain in the string, and a null terminator will be appended to the end of the string. So if you actually specified more characters, it would read up to the line feed and then jump out, and then it gets that new line characters and puts a null character at the end of it. If there is no error, fgets is going to return the pointer, which is the first parameter. It's going to return a pointer which gets returned from the function, and then it's also going to populate the str from pointer as the first parameter. If there is an error, null is returned, and then reading the end of the file cause null to be returned. That means you read all of your strings. So let's look at an example. Here we have our main, and we are creating our file pointer, creating a character string. Here, this is pointer. We didn't allocate any data for it. We just create a character array. We open up the file and reading only because it's R. We said if it is null, jump out. Otherwise, we just say fgets, we read in 60 characters. Or if the line feed is before that, a line feed will come up, and then it will print it out and whatever in the str buffer. So str is that first character that passed in. And then we close the file pointer, set it to null, and return 0. So let's again take a look at this inside of our code blocks IDE. The only thing that changed in this program is really lines 14 to 17. We are using fgets to read our string in, and then we have a str buffer. So we have also need to create a character array up here, which is our str, and we want this to contain 60. We are reading in 60. Well, we will add a line feed, so it's going to read in 59 and then add a line feed to the end of it. So we could say 61. And then the fgets is going to be in an if statement, and it's going to read in each string until it either hits 60 characters or a new line, and it's going to print out that string. You'll notice that's not a while loop. So we are not reading to the end of the file. We read the end of file, we get a null. So if we build this, we want to make sure we have our quotes correctly. Whenever you copy from PowerPoint, it messes up the quotes, and we want to make sure we created our variable C. It's not used, that's okay. So let's go ahead and run this, and you see this is JSON. So actually read in an entire line of text from the file, it reads in the first line. So you would call it again and read in the second line. If you change the number of bytes, read, say we just want to read 10, it would read in 10 and then it would return those 10 as opposed to reading the entire line. So here we just have it this I, so it's going to read in number of characters you second parameter or until it gets a line feed and it stores that in str. Str is a character array. We print it out. Fgets is a lot more efficient for reading because we are not reading a character and at a time we are reading in more data. Reading a character in a time is not as efficient. So now we know how to read in single character. We know how to read in strings until they read a new line or a number of characters. But you can also read in formatted input from a file. So we have getC, fgetc, fgets. And now we have another function called fscanf. This is formatted input. Formatted input is data specified by like has a delimiter or has a specific format associated with it. Sorry. This fscanf function takes a file from stream and then a format. The format is just like the printf format specifiers that you use. So if you want to read in integers or doubles, you can specify data inside the file that are introduced in doubles, and it will read that until it sees like just like the scanf until it sees a white space character. So the first argument to the fscanf function is a pointer to a file object that identifies the stream. We have to know what file we are reading from. Second argument to the function is the format. This is a C string that contains one or more of the following items: white space character, non-white space character, format specifier. The usage is the same as the scanf and then the printf, but instead it's from a file. So inside the double quotes, you can put in text, you can put in white space or non-white space characters, but the format specifiers are really is how you are going to read in the data. And then you specify variables that you want to read it into. So the function returns the number of input items successfully matched and assigned. So here is what it looks like. You will notice that the main is creating 3 character arrays str1, str2, and str3, just 10 bytes each. We create an integer called year. We hit a file pointer. The first thing we do, we open up the file. In this case, we are opening it up for reading and writing. But we are not going to actually write anything to it. We are just going to display what we are reading from it. We check to make sure the file pointer is not equal to null. And then here we are actually putting something in the file fputs. We have not talked about that yet, but this is writing something. Focus here on the fscanf. The fscanf is going to read in formatted data. And so what it's going to do is it's going to read in 3 strings separated by spaces. And so you see the percent as space, percent as space, percent s space, percent d. Then we are saying where we are going to read them into our 3 characters array and then our year, and we have to specify the address operator for our year. But the data is formatted as specific way when it's written. And when you read in something that's formatted, you have to understand the format of the file, how it is written. Here we know that the file is written by separating strings by white space. So that's how we are going to read it in. And so we can read it in with one call fscanf. We can use our form as a specifier as our second argument, and then variable number of arguments for each separate of each comma to specify the data we want to read it on into. And then we just print out that data, the 3 strings in the year, and then again we close the file. And so these are the 3 ways you can read in data from a file. You can either read in character, you can read in strings, or you can read formatted data. And you will notice the formatted way of doing it. It is very similar to scanf. You use formatted specifier variable to read into VA. Hello and welcome back. In this lecture, I want to talk about writing to a file. We are going to concentrate on writing to a text file. What we are going to learn about is how you can write characters, how you can write strings, and how you can write formatted output. The three ways also that we were able to read. So there is a three functions that you really have to be familiar with in order to do these things. The simplest write operation is provided in the function f put c. So just like there was an f put c for reading character, there is an f put c for writing character. This will write a single character to a text file f put c, not as efficient as writing strings, but sometimes necessary. It takes an integer as its first parameter and a file pointer as the second parameter and returns an integer. The function write the character is specified by the first argument to the file, identified by the second argument. So the file pointer represents what it always does, the file that you want to write to, and then the character you actually want to write is your first parameter. The return character is what was written if successful. Remember, if it returns end of file, it means it was failure. If it returns anything other than the end of file, it means it was success. In practice, characters are not usually written to a physical file one by one. It's extremely inefficient. The fputc function is the equivalent to the fputc. You often see this used as well. It requires the same arguments and the return type is the same. The difference between them is that the fputc may be implemented in the standard library as a macro, whereas fputc is a function. So not a ton of differences, but we have not learned about macros. So we are going to stick with fputc for writing single characters. And for an example, it's pretty straightforward. First thing you need to do, as always, you have to open up the file. Before that, we do declare our variables. We declare a file pointer. Should be initialized the null, and then our integer, which we are going to write when we open up our file. You will notice that we do a w or a w plus. W means that we are going to write only. You can't read. W plus means you can write and read. In this case, we can write and read. Here we have a for loop. We are going through all the characters starting at 33 to 100 when these are integers, and this means is the character is represented in the ASCII table. So if you write character, for example, 59, you would have to look it up in the ASCII table to see what it represents. But it would be an actual character. Here we are just writing ASCII values 33 to 100, and we are saying fc char fp, and you could use conversion function if you wanted to create ASCII values and integers. You can just use an ATOI. So if you wanted to write the character C, you could say f put C, ATOI, and then put C in the single quotes. That would be fine as well, because it would convert the ASCII to an integer and write it. But the first argument is an integer, so you have to write an integer. Second argument is our file pointer, pretty straightforward there. And then the last thing we have to do is we have to close that file. We probably also want to set the fp pointer to null, but again, it takes an integer. So be careful there. It's always represented in the ASCII table, but you can convert the actual characters to integers using ATOI. How about writing a string to a text file? Much more useful, more efficient. This is where you use the fputs function. This will allow you to write to any file or a stream. It's similar to the fgets. It takes a constant charge string that you want to write as a first parameter to pointer, and it takes as our second parameter the file pointer, what file you want to write to, and then it returns an int. So the first argument is our pointer, the character string that you want to write. Second argument is the file pointer itself, and the function will write characters from a string until it reaches the null terminator. It does not write the null terminator character to the file, so you have to write it explicitly. This can complicate things because when you read back the data, it could be variable length and it would not end at the null terminator. So you have to expecting it to write a line of text that has a new line character at the end. So make sure you are familiar with the null terminator and either explicitly write it using f_c, a single character, or write it and it will basically add the new line character at the end after you write it. So it's expecting that new line character to be there. You have to explicitly specify that. This is pretty straightforward in terms of code. You just say f open, f puts c, right? F puts writing a string in the new line using the file pointer, and then another f puts here writes another string, and then you close it. So in this case, we wrote two strings, two lines of code actually, or two lines in the file, and we opened up the file with w plus. That's for reading and writing. The right examples are pretty straightforward. You just call a couple functions, f open and then f puts and then f close. Now, for writing formatted output, we are going to use fprintf. Again, you will notice that the f prefix before the function, and you are writing formatted output. So for writing formatted output with fprintf, it returns an integer. It takes a file stream as the first parameter, and then the format specifier are followed by commas with variable name number of arguments for each format specifier, just like printf really. So the first argument to the function is the pointer to the file object, and then the second argument is those variable number of arguments. It's a C string that contains one or more of the following items: white space character, a non-white space character, format specifier, and again, it's very similar to printf, but you are actually writing to a file. So you can write formatted output to a file. If it's successful, it will return the number of characters written. Otherwise, it's going to return a negative number. If it is not successful, it looks something like this. You include the standard IO out header. You create your file pointer. You then use your file pointer to open up some text file. Use it for W plus for reading and writing, and then you just say fprintf. In this case, we are saying fprintf. We are specifying the file pointer, and then we are specifying 4 strings separated by a space, and then a %d. And we are writing hello, my number is 555. So the file is actually going to have the data formatted when you write it. Let's look at this in code blocks and see what it looks like. So there is not a lot of code in here. We only have a few lines of code. On line 4, we are creating our file pointer, and again, we all want to initialize this to null. We then in line 6, we call fopen, and we say open file.txt. So that file.txt has to exist, and either where the C source file is running, or if you are executing the program manually, wherever the executable is, we are going to open up for reading and writing. After we have opened it up, we do want to make sure the file pointer is not null. So we want to say not fv. It's not null. then we can start writing data. And in this case, on line 9, we are going to write formatted data. So what we are going to write is we are going to write one string, two string, three string, four string, and then an integer. And then the next parameter are just comma separated string as well as our integer at the end. I just have to fix these double quotes because it does not work, right? So 555 is right at the end there, and it is going to then close the file and return it. So let's go ahead and try to build this and run it, and we are not going to see any real output for running. We are going to have to look at what the file looks like. So when we compile this file, you want to make sure your if statement says not equal to null. So when we run this again, you are not going to see any output. It's just going to run. And then when you look at the file inside the directory, you will see that it contains the input in a single line. Hello, my name is FPP or at 555. So that's how you can write formatted output. It's pretty straightforward. You could add new lines if you wanted to. It will add a new line at the end, but you could put backslash in here. It works just like printf. Again, we have to run it. We don't really see any interesting output until you look at the file. And in that case, you see a line feed. So writing output to a file is pretty straightforward. You want to write characters, you do F, put C. You want to write strings, F, put S. Formatted output F, print F. Will have some challenge that help you get even more familiar with this, but pretty easy to write output to a text file. Hello and welcome back. In this lecture, I want to talk about file positioning basically. Some functions that will allow you to change the positions of a file. So for many applications, you are going to need to be able to access data in a file other than sequential order. Sequential order is starting at the beginning and then going byte by byte toward the end. That's not always useful because you may want to actually go into the middle of a file and grab data, or at the end of the file and grab data. It all depends on the application. You don't always want to go from the beginning to the end. So there are various functions that you can use to access data in random sequence. There are two aspects of file positioning. One is finding out where you are in a file, and the other is moving to a given point in a file. Those are really the two things you want to find out when you are talking about files and the positioning of a file. What it's actually pointing to, again, where you are in the file itself and whether or not you want to move somewhere else in the file. So you can access the file at a random position regardless of whether you open the file. You can move your file partner. You don't need to open up the file to change where you are, to change, see where you are. So finding out where you are, we are going to talk about first. You have two functions to find out where you are in a file. One is called ftell and one is called fgetPos, fgetPosition. For ftell, the actual function definition is pretty straightforward. You return along and you take a file pointer. And this function is going to accept a file pointer as an argument, and it will return the long integer value that specifies the character position in the file. So it's going to tell you the position. You can use it by creating a variable, in this case fpos, which is going to what's going to get returned, and then passing in that file pointer and calling ftell. The f position variable now holds the current position in the file. and you can use it to return to the position at any subsequent time. So it's going to return your position, F position. This is the way you can get the position of the current point where you are pointing to. The value is the offset in bytes from the beginning of the file. So F10, very straightforward. Use pass in your pointer. It's going to return and tell you where you are in your file based on basically from the beginning of the file until how many bytes from the beginning. So in this example, we are creating a file pointer called fp, and we are creating an integer called length. We are going to open up the file, and this would be for reading only. We are going to make sure it's not null. If it is, we are going to return an error. And then don't worry about the fseek. The fseek is actually just going to go to the end of the file. This is another function that helps us. I'm only using it to demonstrate the ftel. fseek is going to go to the end of the file, and then you are going to say ftel fp, and that's going to tell you you are basically going to be at the end of the file. So the link that's returned is at the end of the file. And so what's going to happen is it's going to return the total size of the file based on length, because you actually moved your pointer to the end, and then you said, where am I? And it said you are at the end. So return the end, and the end is the number of bytes from when you last read. So let's take a look at this inside of our nice IDE, our code blocks. So here's our coding example where we create our file pointer. We see it to null, make sure it's not null. We try to open it up, and then we do an fseek, which is just going to change our file pointer. Ftel is going to tell us where we are pointing to. So it's going to point to the end, and it's going to be any number of bytes to the end. When we run this, what you are going to notice is that displays 24 bytes. So that means you are at the end of the file, because the file is a small file and the file only contains 24 bytes. Typically, you will use ftel after you have done some writing or reading, or after you did it in fseek where you moved somewhere. But it's very simple to call ftel with the file pointer, and then alien len just tells you where you are. You can also use the fget position or fget pose function, and this is a second function providing information on the current file position. It is a little more complicated than ftel. This returns an integer. It takes a file pointer, and it also takes the f position t type. So the first parameter is that file pointer, so you know what file you need to read to. The second parameter is a pointer to a type that is defined in standard io.h. The F position T type is able to record every position within a file. So fget position function is designed to be used when the positioning function fset position. So you use fset position, and then you use fget position. In combination with that, so the fget position function stores the current position and the file state information for the file and position, and return 0 if the operation is successful. Returns a non-zero integer value for failure. So you can create a variable of s position type, and here we say it just here, then we call fget position. We specify in our file pointer, and we specify in our f position type. We have to pass in the ampersand the address of, because it's not a pointer. So in this case, the current file position is in the variable hello or here. So you have to declare a variable of type f position t, because that's what you pass in your parameter, your second parameter. You can declare a pointer of the type F position T star because there will not be any memories associated to store the position data. So let's look at an example. This will make a lot more sense. In this case, we create our file pointer, we create our F position, T type position, we call open and then we call fget position. And we pass in our file pointer in our end position. So that's where we are storing the position. We are going to get the position where we are at. Then when we say F put S, we are writing some data to wherever we move to. So again, F get position and F tells you where you want to. Actually writes to or read from. It's somewhere in the middle. It's not at the beginning. It's not at the end. You are moving. You will usually move with seek or your move with something and get position, and that tells you where you are at. So F get position and F tell is going to tell you exactly where you are pointing to, and that means you can move somewhere else and you will be able to read. Now, setting a position in a file up until this point, we are just reading in where we are at. We are not going to really read in where we are at unless we set something. We did a read and write. So as a complement to ftel, you also have fseek. And fseek is going to allow you to move somewhere for your position. It returns an int. It returns a file pointer, a long fset, and an integer original. The first parameter is a pointer to the file you are repositioning. Second and third parameter define where you want to go in the file. The second parameter is an offset, where a reference point is specified by the third parameter. The reference point can be one of three values that are you specified by the predefined names: seek, set, seek current, and seek end. Seek set define the beginning of the file, seek current define the current position in the file, and seek end define the end of the file. So for a text mode file, the second argument must be a value returned by ftel. So you should notice that with fseek and ftel, they are used together. So the third argument for text mode files must be seek set. For text files, all operations with fseek are performed with reference to the beginning of the file. For binary files, which we have not really learned much about. But for binary files, the offset argument is simply a relative byte count. You can therefore supply positive or negative values for the offset, then the reference point is specified as seek current. So let's look at an example. Here in this example, again, we do the outputs. So we write some data to our file and then we use fseek. Fseek is going to move you. Here this is saying you are going to move 7 bytes and you use seek set to say we want to move somewhere basically 7 bytes from the beginning, and we can move from the beginning of the file by 7 bytes. That's going to move to. And after even bytes, we can then actually write data to it, and we would also be able to use ftel to see that, oh, after 7 bytes where we are. You can use the information to retrieve back from where you are. Again, the whole point of the fseek and the fgets is you are either seeing where you are located to specify where you want to write to or read to. So fseek is actually going to move the position. Tel is going to tell you where you are located. Fset position is also like fseek, but fset position is a little more complicated. it will go with the fset position. So fset get position is also very similar to fset position. With the fset position, it specifies the first parameter as a pointer to the open file. The second parameter is a pointer of the f position t type. The position that is stored at the address was obtained by containing fget position. So fset position has your file pointer and then your actual variable, and the variable has here was previously set by a call to fget position. Again, you are going to use fset and fget together. The fset position returns a new zero value on error or zero when it is successful. This function is designed to work with a value that is returned by fget position. So you can only use it to get to a number in a file to get a place in the file that you have been before. fsig allows you to go to any position just by specifying the appropriate offset. So here we look like we have our f position, t type position. We open up our file and then we call fget position. In fget position, we are specifying where we want to move the pointer, where we are actually reading or writing in the file. Then we use puts to wherever we moved it to. And then fset position is going to again set something specifically where we want to write to, and then write it from wherever we want. So with all these functions, you want to actually see where you are pointing to. This will become more easy to understand once we have our challenge. So with reading and writing, you always want to move somewhere to the point of that you are writing to. You don't always want to write for the beginning of the end. And so these functions are very useful. Hello and welcome back. We have our first challenge for doing some file writing and reading. Specifically in this challenge, we are just going to read in some character, get you familiar with the fputc function. So what I would like you to do is I would like you to write a program to find the total number of lines in a text file. So you need to create a file that contains some lines of text. You are going to have to create a file. Remember, this file has to be placed in either where the executable is, and then you can double click the executable and run it in the same directory as that. Or if you are running it from the integrated development environment, you are running it from code blocks, Visual Studio Code, then you can put your text file inside of your wherever your source files are located, wherever you saved your project inside your C source file. So you will have to create a file before you can actually write this program, because you need to read and write some data inside that file. You are going to need to open your text file up. We are going to need the fopen call. This is going to get you familiar with the basics. You need to use the fgetc function to parse characters in a file that you get until you hit the end of file, the end of file. So if it's end of file, you can increment the counter before you reach the end of file. That's how you are going to be able to count the lines. So you can just create a local variable for the counter, and what you want to do display is you want to display as output the total number of lines in the file itself. So this is going to be basic program that gets you familiar with the basics of the file input and output. Specifically, always want to open up a file using fopen. We are going to get familiar with that file pointer. We are going to have to close our file, and then we are going to use that important fputc function. So while loop, you are going to have to create a local variable that's just a counter, and as you are reading in each character, you can compare the character to the line feed. that return it. And if you have a line feed, then you want to increment the counter so that you can count each line. Whole process of this function is to count the number of lines in a file. So good luck. Another challenge for you regarding file input and output. Specifically, I want you to write a program that converts all the characters of a file to uppercase and write the results out to a temporary file. Then I want you to rename the temporary file to the original file name and remove the temporary file name. So you are going to be doing a number of things for this assignment. You are going to learn how to both use the fopen function using temp file. You are going to use the rename. You are going to need to use the isLower function to check for whether or not characters are in lowercase, because we want to convert them to uppercase. So if it's lower, you want to convert it to uppercase. And we are also going to use the rename and remove functions because we are going to use temporary files here. So you need to use the fgetC and fputC functions because we are going to be using reading in characters because we are doing conversions. You want to use the rename and remove functions because you only want one file to exist at the end. So you create your file, it has some contents in it, then you create a temporary file which you end up deleting, but first you rename that to the original file. So you want to create your temporary file as well, and then you want to use the isLower function to check as you are reading in each character if it's lower character. You want to convert it to uppercase. You can convert an character to uppercase by subtracting 32 from it. So if you do fgetC, that's going to return to an integer character or a regular character, char. You can basically just call the isLower function on it, pass in the char character data type, and then you can basically say character equals character minus 32, and that will convert it to uppercase. Because remember, characters are part of the ASCII table. So you are going to create two files, a temporary file and the file you want to read that you already exist. So you have to create a data file that just contains some data in it, and you want to close both of those and then rename and remove the end. So you are going to get pretty familiar with using fgetC, and you will also have to use the fgetC to write the data to a temporary file whenever you are converting the string. So you are going to convert the string, and then the conversion whenever you convert the string, you are going to convert the character, and then the conversion of the character you are then going to do and fputC on that file. So I hope this is going to be helpful. If you have any questions, you can always email me. Okay, last thing you want to do as part of the program is display the content of the original file to standard output. So you are going to read again. I don't want to have to open up the file to test. You could read the data, look for the lower case and then convert to uppercase and then open up the file manually. But I don't want to look at the file. So I want you to print it out. So you are going to read, write, and then read again as the last output, but the end result, again, you only have one file created. The temporary file is just going to create the temporary file, then you are going to rename to the old file. Hello and welcome back. In this challenge, I want to help you become familiar with changing the position of a file. So what I want you to do is, I want you to use the fseek and the ftell functions to be able to basically change the position, so you can point to the middle of the file as opposed to the beginning or the end. So you are going to write a program that's going to print the content of a file in reverse order. You are going to use the fseek function to seek to the end of the file. So you are going to start reading from the end of the file by moving the position to the end of the file. You are going to use the ftl function to get the position of the file pointer. So fseek is going to move the position that you need to get the position using ftl to then start doing your writing and reading. You want to display as output the file in reverse order. And so these are going to again be some basics here. You are going to need to create your file beforehand. Some simple text file that contains whatever you want inside of it. And then you are going to need to create a file pointer, and you are going to open up that file and read only as you are reading in the file. Before you start reading the file, you can seek to the end of the file using fseek method. Once you have used the fseek method, you can then use the ftl method to get the actual position. You then can use the position to start printing out of the characters using fgetc. So we want to get the position of the pointer, and we want to use that to be able to seek to the end and display some information. The reason we need to use the ftl is because then our while loop knows when to exit. So we want to use ftl for the number of bytes, and we can increment our counter. And so we are going to basically go from the beginning to the end using the counter and then printing it in reverse order. So these are the functions we are going to use. There are many different ways to implement this, just one. If you have any questions, please ask.